Hello and welcome to this look at an applied, quite tricky ion testing question. So I'm going to start by just taking you through the beginnings of the description of what the student in the question has done. So they have a 5 gram mixture of sodium chloride and barium nitrate, both of which are in the solid form. You can see that from the two state symbols there. Now what the student wants to do is to work out the percentage by mass, or the proportions rather, of the two salts. Now it doesn't say that in the particular part of the question, but I'll come on to the second part where it starts asking you to do things in a moment. So they've 5 grams of a mixture of two salts, but they don't know what the exact proportions of each one are. So the stepwise procedure they're going to carry out will only deal with the barium nitrate present, because the barium nitrate contains Ba2+, which will react with Na2SO4. So the first thing they want you to do is to write an equation for the formation of barium sulfate in step 2. Now, by the time you get to step 2, the barium nitrate that was in solid form will have dissolved in water in step 1. So if you're going to include the state symbols like they say, you need to be quite careful to make sure that the barium nitrate is now in aqueous form, not solid form. And obviously the barium sulfate precipitate has to have an S next to it. So the next thing that they want you to do is to work out the percentage by mass of sodium chloride in the original mixture of two solids. So the calculation method is in that box. What I'd like you to do is maybe pause and try this out before continuing. Okay, welcome back. I hope you've had a chance to have a go at some of those calculation steps. So I'll take you through what we do. So it told you earlier in the question that barium sulfate has 233.4 grams per mole as its molar mass. And the first thing to do is to work out the number of moles present in the 3.28 grams of precipitate that was formed. So notice that I've put a dot dot by the 0.0140. That's because I'm keeping my calculator value. So that barium sulfate would have come from an equal number of moles of barium nitrate solid in the original mixture. So I can transfer that 0.01400 moles across. Now I need to know what mass of barium nitrate this number of moles represents. So I multiply that by the molar mass given to me, which is 261.3 grams per mole. And I get 3.672 ... Obviously it's a longer number, I've truncated it slightly. And then I subtract that from my original 5 grams to give me, by difference, the mass of sodium chloride that must have been present in the original mixture, which is 1.3279. So that then gets expressed as a percentage, and that gives us 26.6 as 3 significant figures. Now the next thing to do is to have a look at an addition, or an alteration rather, to the method. So the student adds an excess of silver nitrate solution. Now what this will do, it will react with the sodium chloride in a 1:1 mole ratio to form a silver chloride precipitate. So this change would allow the student to determine the percentage, but this time what they'd have to do is they'd filter dry and weigh the silver chloride precipitate. Now because the moles of silver chloride would equal the moles of sodium chloride in the original mixture, because both substances have the same number of chloride ions per mole, you can convert the mass of silver chloride to moles, and this would allow you to calculate the mass of sodium chloride present in the original mixture. Okay, so I hope this has been a useful look at what's actually quite a tricky question. And thanks for listening as always. Until next time, see you soon.